Okay, page table 249. That's question 3. We're asked to study the diagram of a coordinate plane below and fill in the coordinates of A, C, and E in the brackets in the diagram. Part 2, we're asked to find the area of the rectangle ACEO, which is the dotted rectangle there. Okay, so if we fill in the coordinates of points A, C, and E, let's do point A first. I know A is in the y-axis, which means its x-coordinate is 0. And the height of the point B vertically from the x-axis there is y1. Therefore, A will have coordinates 0, y1. C is out a distance of D, which is x2, and up a distance of B, which is y1, same level as A. So y1 for its y-coordinate and x2 for its x-coordinate. The point E then is on the x-axis, therefore its y-coordinate is 0, and it's out the same horizontal distance as dx2. So those are 3 points filled in correctly. And you're asked then to find the area of the rectangle ACEO. ACEO, length of E, which is a coordinate of x2, so length is x2. And the height of y1. Therefore, area is equal to x2 y1. Okay, so over the page on page 250, part 3 of that question asks to find the area of the triangles ABO, BCD, and ODE using the formula for area of the triangle on page 9 of the log tables. Part 2 then proves that the area of OBD is equal to half x1 y2 minus x2 y1. Now the formula for area of a triangle on page 9 of the tables is half AH, which is that formula there. I don't use the sign C because I'm not given any angles. Okay, so let's go for ABO first. Again, triangle ABO is this triangle here. Okay, so that triangle ABO has, just fill in those again, that's 0 and y1. And this triangle you can take. So if I take the base of the ABO triangle as this top line here, I know that the distance from A to B is x1 along the x-axis there. That's the distance of x1 for my base. And my height will be the height of y1. Okay, so if the area is a half base by height, as page 9 in the log tables has, triangle ABO will have an area of half of base x1 times height y1. Okay, now for the triangle BCD next, that won't be as easy, so let's go back and see triangle BCD, which is this guy here. Okay, and remember there that the point C has coordinates x2, out x2, up y1. Okay, now the distances along the base and the height here for triangle BCD will be y1 minus y2 for C to D, so that's the vertical. So we have y1, which is the taller one, take away y2, the shorter one, which give you the height there from C to D. Horizontally then, from B over to C, it's the x2, the longer one, minus x1, the shorter one, which gives me now the base and the height. So for my triangle BCD, using the same formula, half the base now is x2 minus x1 by the height, perpendicular height, y1 minus y2. Finally, triangle ODE, so that's ODE, this is the last one here. That triangle there will have a base of, again, the coordinates E are x2, 0, at x2 up 0. So that means that the base will have a length of x2, the height will have height of y2, which gives me the area of triangle ODE equals half times base x2 perpendicular height y2. Okay, now those are your three areas. Part 4 of the question, prove that the area of OBD, and OBD, if you remember, is the inside shaded triangle. So that triangle you must show has an area of a half x1 y2 minus x2 y1. Now, I take my rectangle, A, C, E, O. That has an area, if you remember from part 2, of x2 y1. And that is simply the outside dotted rectangle. Okay. Now, if I subtract all the shaded areas here from that outer rectangle, I'll have my inner area there. So what I need to do is I need to subtract to find the triangle OBD area, which will be equal to the rectangle x2 y1 minus the three triangles summed above. That's a half x1 y1 plus half x2 minus x1 times y1 y2 plus half x2 y2. Okay, so let's tidy up the brackets. So the area is still equal to x2 y1 minus, okay, it's a half x1 y1 plus a half of x2 y1 minus x1 y1 minus x2 y2 plus x1 y2. So that's those two brackets worked out there, plus a half still of x2 y2. Okay, so it's equal to x2 y1 still minus half x1 y1 plus getting rid of those brackets gives me half x2 y1 minus a half x1 y1 minus a half x y2 plus a half x1 y2 plus a half at the end there x2 y2. I can see some cancellations there now. The x1 y1, half of that, take a half, that gives you 0. And the negative half x2 y2 added to half x2 y2 gives you 0 as well. So I'm left behind with x2 y1 minus, what's left behind? A half of x2 y1 minus, careful the minus outside the brackets there, so half x1 y2. Now a full x2 y1, take a half x2 y1, gives me a half x2 y1, half left behind, and or subtract from that a half x1 y2. Or if you like, if you take the half outside, we're left with a half on x2 y1 minus x1 y2. Now, depending on what those coordinates might be, you have to take the modulus of that. Now the modulus can incorporate half, so I'll take the modulus. So it could be a half x2 y1 like we have, minus x1 y2, or half of, with that by minus you get x1 y2 minus x2 y1. So both those will do, and this is the one they want us to show.